Hi, this is Ed Olzanowski, and today I'll be going over the critical path method, which is a section of the introduction to project management. Specifically, it's related to the knowledge area of schedule management, create project schedule. This area is one of the most difficult parts of project management for project managers to understand. So I'm making a video series here to help explain how to do a critical path method step by step. First, I'd like to go over the box. Each activity that we're going to create in the critical path method, it has a standard definition that you can put together. You can change it up the way that makes sense to you, but this is typically the way industry uses it. We always have the ID. Usually you'll see A, B, C, D, E, whatever the sequence is, that will be the ID, and the activity name. Usually it's a short, brief verb, noun of what is being done. And then through a table or other means, you would get a duration of that activity. Once we have that duration activity, we would eventually figure out what is the predecessor or successor tasks or activities. And then from that, we can start calculating what our early start of this task is, or this activity, what our early finish is through a forward pass. And then we're going to calculate what the late finish and late start is doing a reverse pass. Once those two are done, we can go back and figure out what the float is or slack. I'll go through each one of those steps now. So when you're setting up your activities, always try to set it up the same way so that you won't get confused by numbers and other annotations. Here's an example of a table where they give us a list of activity definitions. And they also put the sequence or the ID in here, which is A, B, C, D, E, F for each of these tasks. Each task, they identify what the predecessor is or what predecessors precede this task and the duration in weeks. We're just going to use a number 2 instead of 2 weeks. We'll just put 2 in there and we'll represent A. So in this case, we have A acquisition plan and it is 2 weeks long. We'll go to our next task, B, which is statement of work. It has a predecessor of A and it's 6 weeks long. So we basically draw an arrow. This is also called activity on node, where your activity is inside of a node. We label it with B, a 6-week duration. Predecessor, just like it says here, has A. A must be finished before B can start. Then we go to our next one, C, specifications. It also has a predecessor of A with a 6-week duration. So we'll do the same thing here. We'll mark it as C, specification, 6 weeks long. Continuing on, D, special provisions, has a predecessor of both A and B, both A and B. So we'll draw arrows from A and B to D, and we'll mark it as 2 weeks, as indicated in the table. Next, we have contract data requirements, which is item E, and it has a predecessor of D, which is our special provisions. So we'll put an arrow with an E on it for contract data requirements, and it is a 4-week duration. Finally, the last step is assemble RFP. Its label is F, 2 weeks long, and it has predecessors with B, C, D, and E. B, C, D, and E. So we draw arrows from all of those into F, and we label it as 2 weeks long. This is basically a quick way to do a activity on node diagram, and it's the beginning of our forward pass process. So I'm going to restructure this activity on node diagram so we have a little bit more room on the next slide. First step in critical path method is doing a forward pass. You'll notice I put a plus sign here and I labeled it red, and I'm showing that it's going forward through the project plan this way. This plus sign is significant because everything you do going forward is we're adding. So we're going to be adding days as we go forward. And we'll get more into it. I'll show you some examples. Well, when we start off a project, we could call it 0 day. So in this example, we're going to do 0 days. So we'll start off with day 0. And all we're going to do is add, just like it says here, 0 plus a duration of 2 means we finish on the end of day 2. Pretty simple. Next, we'll take this 2, and you'll see these arrows, they just point to the next cell. all these activities can all start after activity A is completed. Well, if activity is complete, A is completed on day 2, we just put a 2 over into the next field for B and for C. I'm holding off on D for a reason, because you'll see there's 2 arrows point to it. And this is significant. I'll show you in a second. So we'll take this 2 plus 6, same thing like we did here. We did 0 plus 2 is 2. Here we do 2 plus 6 is 8. Down here, oops, I'm sorry, we go to the merger here. So this is called a merge. Whenever you see this where 2 arrows are merging, this activity cannot start until both of these activities are finished. Well, it's kind of simple if you look at it this way. What is the earliest this activity can start? It can't start on day 2. It has to start on day 8. So whenever you see a merge, we have 2 or more arrows pointing into a box during a forward pass. Always pick the larger of the numbers and put it in the early start. So look for the merge. 8 is the higher number, put 8 here. 8 plus 2 is 10. And then we'll continue down here. 10 gets transferred over to E. E, 10 plus 4 is 14. 2 plus 6 is 8. And then look what we have here. We have another merge. Remember, we pick the larger of the numbers. So we have an 8, 14, 10, and an 8. So we're going to pick the larger one, the 14, and we'll put the 14 in the early start. Last step is 14 plus 2. That's easy. That's 16. We have completed our forward pass. So the significant things to remember here is you start at 0. You're just adding in. As long as there's not 2 arrows going to the same box, you just move the 2 over to the next cell. And when you get a merge, you always pick the larger of the 2. And then add the duration until you get to the end. Now we're going to do a reverse pass. Reverse pass is, I put a negative sign here because you subtract going backwards. And I'll show you how that works. One of the biggest mistakes that project managers make when they're doing the reverse pass, they forget the very first step is to drop the last activity, this activity here, F, the early finish to the late finish area. So we're basically going to move this 16 down into the late finish area. So the 16 just drops down. On the last task of your activity diagram, you always move down the last early finish to late finish. Now to calculate, we just subtract the duration from the late finish. So late finish is here. Now we're subtracting 2 from it. That gives us 14. Take that 14, move it over to the next cell down here. And we can also move it here. We subtract 14 from 6, and that gives us 8. 14 from 4, that gives us 10. Now we got a situation. We have 2, if you're going backwards where we have the merge, we actually call this a burst going backwards. You'll see that this bursts out. When you have 2 of these, the formula is, or the rule is, you always grab the smaller of the bottom numbers. So here I have a 10, here I have a 14. Always grab the smaller of the 2. Remember, it's a minus. We're minusing. Think of minus as the lesser of the 2. So we have a 14 down here that's pointing to D. We have a 10 in E pointing to D. We're going to take 10 and move it over. 10 minus 2 is 8. And then here we have the same situation. We have a burst. In this burst, we have a 8 and a 14. So we're just going to take the 8, that's the lower of the 2, move it over into the late finish, subtract 6, and we get 2. Bring the 2 over. Actually, we have another big merge. We have 3 of them. We have 8, 8, and 2. The rule is use the smaller of the numbers. 8, 8, 2. So we know that 2 comes over. 2 minus 2 is 0. If you ever end up with a number besides 0, your math is wrong somewhere in your activity diagram. So go back and check your math again. Okay, the next step is to identify a critical path. And a critical path in the PMBOK is defined as a sequence of activities that represents the longest path through the project. It determines the shortest possible duration. I know that sounds confusing, but if you think about it, it's the longest path throughout the project. It means it's the shortest amount of time we can get something done. And it also determines the earliest possible date that the project can end. So let's give an example of that here. I'm going to show you how to calculate that. We call it float or slack. So for each activity, we're going to calculate what the float or slack is. The way we do that, real simple, either subtract the late start from the early start, or you can even pick the late finish from the early finish, the first two numbers or the bottom and top numbers. So always on the same side of the square, though, don't mix and match. 2 minus 2 is 0. There's no float or slack in this activity because it just started. Let's check the next one. 8 minus 8, 0. 10 minus 10, 0. We can continue on. 14 minus 14. Here we do 14 minus 8 and we come up with 6. So we have a float of 6 on this activity. That means this activity can be delayed for 6 weeks before it impacts the end of the project. So we do have a 6-week float on this activity. And this last activity has 0 float. So to calculate our critical path, all we do is follow the zeros. So you see from A to B, there's zeros, and all the way to F, that's a 0. So there's one of our critical paths. But you also notice there's several other critical paths. We also have A to D to F, and then we have these other ones, B to D to E to F, and you probably can find 5 total critical paths, meaning add up A, B, D, E, F, that's 1, A, B, D, F, that's 2, A, B, F, A, D, E, F, and A, D, F. So there's 5 critical paths in here in this one activity diagram. The only thing that is not on the critical path is ACF, that path there. Let's look at another example. This is one that we're going to go through pretty quickly. It's just a network diagram or a network diagram for cake baking project. This one here, we have some durations down in the bottom here. In this activity, they show the durations in the bottom and they label them A, B, C, D, E, F like our other one. This is just an example to remember that early start is in the top left, early finish is in the top right. You have your duration and you have your late start, late finish. They're putting slack on the far left. We'll get through this whole thing and I'll show you. So we know we start off with 0 days, 0 plus 7 is 7. And we can quickly go through this where the 7 gets carried over to each one of the activities, B, C, and D. We add 2, that gets us 9. 7 plus 6, 13. 7 plus 3 is 10. Remember, we're doing a forward pass, we're adding. This activity cannot start until the latest task is finished, which is 13. Remember, we always pick the larger one when we have a merge. So we pick the 13. And then we have another merge here. We got a 17 and a 10. Always pick the larger one. Then we do a reverse pass. Remember, we bring that 42 down. A lot of people forget that. Bring that 42 down to the bottom. And then we do our subtraction. 42 minus 25 is 17. We bring the 17 over to both areas. 17 minus 3 is 10. 13 minus 6 is 7. 13 minus 2 is 11. Now here we have that burst I told you about. Remember, when we're doing a backwards pass, we always pick the lower of the numbers. So you have a 10, a 7, and 11 as the late start. You always pick the lowest number, and we bring the 7 over. 7 minus 7 is 0. Now from this, you can easily see if you subtract 7 from 7, that's a 0. 13 from 13, that's a 0. 17 from 17 is 0. 42 from 42 is 0. So you can quickly see where the critical path is. Down here, you'll see that 17. So you want to go back again. You'll see here 17 minus 10 is 7. That would be a float of a 7. And 13 minus 9 is 4. So these have float on both of these activities, so they would not be part of the critical path. The critical path would A, C, E, F. So that's one way you can do it through the network, but there's also another one called enumeration. I'm gonna show you how we can do the enumeration and identify the path quickly. The way you do that is you just follow the paths A, B, E, F, and you total up those numbers to the durations. 7, 2, 4, 25, that equals 38. A, C, E, F. You add those up, you get 42. And the last one is A, D, F. Add those up and you get 35. Remember the definition of critical path. It's the longest duration through a project network diagram, which is 42. So this automatically tells you another way of determining what your critical path is. Here's some references in case you want to look back to see. You can go to the PMBOK. The PMBOK actually gives you some definitions that we went over, and also look inside your book and make sure you practice. This is one of the most difficult areas for project managers.